Okay, so mean value theorem. This is basically like 4.0, but then it's more specific, okay? So first of all, you guys know intermediate value theorem from like the last chapter. Now you guys have mean value theorem. I know we talked about Rolle's theorem, but Rolle's theorem is a type of mean value theorem, so you can always just refer to mean value theorem, okay, instead of Rolle's. Rolle's is when the slope equals 0, so you set the derivative equal to 0. Okay, we'll talk about this a little bit more. All right, so as a reminder, what is intermediate value theorem? Intermediate value theorem is when you have some continuous function, so continuous function, and then you have a closed interval, so between here and here, if it's continuous, and you have these y values, right, at like 2 and, I don't know, 5 or whatever. So we're saying that intermediate value theorem is saying if it's continuous and then the y values are between 2 and 5, then there has to be at least one time where the y value is 3. So here the y value is 3. Can you find that point C? You can. Does it have to be only between 2 and 5? No, it can go lower, it can go higher. We don't know. All we know is at least once we're going to have a value of 3 as our y value. At least once we're going to have a value of 4. What is this example talking about? It's saying if you have a negative y value and a positive y value, so if you have f of 10 equals -1, f of 20 equals 1, there must be at least one x-intercept. Why would that be true? Because if you have a -1 and then you have a +1 and it's continuous, then you're going to go through that x-intercept. You're going to have a y equals 0, right? So you're going to have a y equals 0 in between a negative and a positive, which is the x-intercept, which is the solution. So a lot of times, instead of using this and saying in the middle, in between, there's some number, a lot of times they refer to like there's an above, there's a below the y-axis, there's a positive and a negative. Does it, where are there solutions? And you'd be like, yes, there's at least one solution because of intermediate value theorem. So notice that the intermediate value theorem, it talks about f is continuous on that closed interval. We've written this a lot. The mean value theorem, you need two things to be true, okay? So for mean value theorem, we need the continuous on the closed interval. We also need differentiable on the open interval. That has to be true as well. Differentiable just means you can find a slope. How come you can find a slope after A? Because at A, you have an end point, right? This is an end point. It includes A. So if you have an end point at A, then there's no slope at A. There's a slope after A. There's a slope before B. So at B, you can't have a slope because that's an end point. So it's differentiable on an open interval, okay? And it's saying, okay, if that's true, then there has to be, and we did this on our 4.0, remember? So there has to be a place where old school slope, which is from A to B, so that line, that secant line, the slope of the secant line, that old school slope, equals some sort of derivative. So where would that be if we were to draw a line parallel to the old school slope? It would be somewhere here, and then you would have like a point C, and that's what you would be looking for. Like when you solve for everything, that's what you've been looking for. So we're just saying slope equals slope. Derivative equals old school slope. So that's what we like to say, right? Derivative equals old school slope. But really it's slope equals slope, which makes sense. A slope is a slope is a slope. So it has to be continuous and differentiable. Okay. Does it have to happen one time? Yes. Can it happen more than one time? Technically, it could. Like if this was A and B was over here, like if this kept going and B was over here, I would have this parallel, and then, well, actually, A to B would be like, here. So I would have a parallel up here, and then I would have a parallel down here. So it can happen twice. It can happen more than twice. It just kind of depends, right? It depends on what you're looking for and what the endpoints are. Okay, so for the first part, it says determine if it applies, and then what conclusions can be drawn. So we're actually going to solve for C if MVT applies, okay? So does MVT apply? We look at this, we imagine it. What's going on here? What's wrong with it? So thinking about the domain, oh, X can't be 1. 1's in here, MVT doesn't apply. You're gonna list 4 things. So you're gonna tell me, is it continuous? If it's not, then why not? If it's differentiable, and then if it's not, and then why not? So here are the 4 things I want from here. So no, MVT does not apply. F of X is, and I want 4 things. Not continuous on this closed interval at 1 because there's a vertical asymptote. So I would like 4 things. Like whether you have, if it's a yes, I'll tell you what I want. But if it's a no, I want 4 things. Not continuous on what interval, where, why. Okay? Okay, how about for this one? Well, this one, you know it's like all smooth and continuous, right? So this one, yes, it's going to work. If it's going to work, tell me where it's continuous and where it's differentiable. Tell me what's going to happen. So this is how we write, this is how we verify, okay? So continuous on the closed, differentiable on the open, therefore MVT guarantees a C such that the derivative equals the slope. Okay, so then we did this on our homework a couple of days ago or over the weekend. And then you find your derivative, you find your slope, and then you set them equal, and then you find 2 values, or sometimes 1 or sometimes 3. And then we look at those 2 values and we look and see, do those fit? If they both fit, then they are both answers and we're all good. Now you're going to do this one. I already showed you that, but that's okay. So does this work is the first question. Well, you have an x equals -1 that doesn't work. Do we care about that here? No, we don't care about that here. So it does work. So we're going to list that it's continuous on the closed, differentiable on the open. We're going to be able to find that. Okay? We're going to be able to find the derivative and the slope and set them equal. So you're going to do that now. You're going to pause it and do that now and not just copy me. Do it for real. Okay, and then when you do it for real, this is another paper, okay? So when you do it for real, you get the derivative equals this, right? And then you get the slope equals 1/4. And then you slowly work at it, and then you set this equal to, it's -1/4. So over here I got -1/4. I did my work somewhere else to get the slope. I set them equal. I make them both positive. I cross multiply. I get everything on one side. And then I factor, and I get 2 answers. Okay, my 2 answers are -3 and 1. Are they both real answers? No. Because -3 is not in my interval of answers, okay? So there's one point where that happens and C would equal 1, okay? So these are just final statements. This is like amazing. If you did that, it would be super amazing. It would maybe be some extra credit, okay? So like for this one, we found our 2 values and then we made a statement. We said this equals this, which is already stated up here. Somewhere we've stated it before. So this equals this at 2 points where C equals this and C equals this. And then it's stated again. So this equals this, which we stated up here already on that other paper, at 1 point where C equals 1, because that one doesn't count. Okay, so making a final statement, I love it. Maybe some extra credit on like all of these kinds of questions. Okay, so how about on the back? All you're doing is, let me get another paper. So all you're doing is you're taking a look at it and you're going, does this apply? Oops. Does MVT apply? Yes or no, but you have to list 4 things, okay? So if it's a no, is it because it's not continuous? Is it because it's not differentiable? And then tell me where and tell me why. So this is continuous, but it's not differentiable. It's not differentiable on this open interval. Notice I underline the parts that I'm going to be looking for, okay? So no is your answer, but you're going to say not differentiable on that open interval. Why not? Because at 3, there is a corner. So I can see it with my eyes. Okay, how about something like this? Does MVT apply? So this just says, can it be applied? So really it's a yes or no, okay? But I want like those 4 things if it's a no. So does this apply? Yes. So why does it apply? Tell me why. It's continuous on that closed, differentiable on that open, okay? I didn't ask you to solve for anything. You could, but I didn't ask for that. Okay. How about something like this? I know I wrote this already. So think about what this looks like. This looks like a V. And then right here, this minus 200 tells you to go down. Does that really change anything in my x coordinates though? No, it doesn't. So is this okay on that interval? No, it's not okay. It's continuous, but there's a corner down there at -5, which is in that interval. So I'm going to list those things. It doesn't apply. How come? And then where and why. So not differentiable on this open at x equals -5 because there's a corner. So 4 things I'm saying. Okay, and then how about this one? So on your paper, it's something like that. So you have to think about what does that look like when you have a cube root? And what does that mean? So this just means you're going up 1500. Does that matter to our No, that doesn't matter. It's just going up and down. Okay, what does that look like? It looks something like that. Right there is x equals 0, and then it's just moved up to 0, 1500, right? So is that going to work for MBT? So is it continuous? Yes. Is it differentiable? Well, it's not differentiable at 0. Do we care about that? My initial answer was, yeah, we care about it. But then I realized it is differentiable on the open interval. It's not differentiable on 0 because there's a vertical a vertical tangent, but it's differentiable after the 0, and that's what we care about for differentiability. So yes, it does apply. It's continuous on the closed. It's differentiable on the open. If you were going to solve it, which I didn't ask you to, you would do that, and then you would solve it, and then you would get a decimal because you would plug it into your calculator and get that decimal. Right? Right. Okay, so it is possible. I didn't ask you to do that part, but it is possible. Okay, on the homework you will have to do that a little bit. Okay. I think there's one more. Yes. Right here. Okay, you have to know what that looks like. So this is what it looks like. Does MBT apply? Is this continuous on that interval? No, it's not. Because where does this start? It starts at x equals 3. What happens at x equals 0 and 1 and 2? Nothing. There's nothing there. So it doesn't apply because it's not continuous on that interval because that function does not exist on that interval. So tell me 4 things. Either it's not continuous or not differentiable, and then tell me the interval. For continuity, it's closed. For the other one, it's open. And then tell me what happens where. So this is what happens, and this is where it happens, right? This is what happens, and this is where it happens. So tell me 4 things when it's a no. When it's a yes, you have to list this, you have to think about these things, and then I might ask you to solve for C as well. Okay, so there is your mean value theorem, and you're getting more practice with it. All right, I will see you